Hello everyone. In this video, let me discuss about is a transform problem number 2. Find the is a transform and ROC of the following: x of n equal to minus a power n u of minus n minus 1. Write the solution. Given data, x of n equal to minus a power n u of minus n minus 1. Right? Right, is a transform formula. Is a transform equal to is set of x of small x of n, that is nothing, capital X of z equal to is a transform formula summation n equal to minus infinity to infinity x of n into z power minus n. Okay, next substitute x of n, that is given data. So x of z equal to x of n, substitute here. Instead of x of n, you are write minus a power n u of minus n minus 1. So, summation n equal to minus infinity to infinity minus a power n u of minus n minus 1 into z power minus n. See here the limit is given, right? Limit is given. This limit is only used for apply the limit purpose only. Okay. So, u of n, write the u of n statement. There is a limit u of minus n, here minus 1, right? So, here 1 for n less than or equal to minus 1 and 0 for n greater than 0. This is the limit. Okay, how to calculate means, see here, take this range n less than or equal, that is minus n minus 1, right, equal to 0. So minus n equal to plus 1, so n equal to minus 1. So the limit range from minus 1 to infinity, minus 1 to negative side. No, so minus 1 for negative side. This is a timeline. See the timeline. This is for plus infinity, minus infinity. This is for 0. The limit start from minus 1 to infinity. This is the limit range of given problem, right? Okay. Next step, x of z equal to, change the limit. Here the lower limit n equal to minus infinity to minus 1. Once limit applied, no need to write for u of n part. Okay, so minus a power n into z power minus n. Then next step, take minus n outside. N equal, summation n equal to minus infinity to minus 1 a power n into z power minus n. Here next step, right, minus summation, here the limit change, change to be positive manner. So here next negative side change to be positive side. So once the limit interchange, that is positive, means inner term sign also sign change. Okay, here a power plus n, no, so can be replaced by plus n, can be replaced by minus n, and minus n can be replaced by plus n. Next step, right, a power minus n z power plus n. Okay, because of the limit change, because of the limit change. Okay, here write the statement. Change into positive limit, that's correct. Here negative limit minus infinity to minus 1 can be replaced by 1 to infinity, that is negative part can be replaced by positive part. Here negative limit changes to positive limit, that is nothing. Here given problem minus infinity to minus 1, that is nothing, negative part, no, so this can be replaced by positive part, 1 to infinity. So automatically inside of the term power sign will also change. Okay, inside the term power also sign change. Okay, equal to minus summation n equal to 1 to infinity a into that is a inverse, right, into the whole power n. For the both term, the power n is common, take it as outside. Okay, that's common. Next step, ordinary simplification. There are two methods to simplify this technique. I will explain two methods. Method 1, method 1 here, x of z equal to, here see, this is a limit, no, see here, this is a limit, this is for positive part, this is for negative part, This is for 0. This is for minus 1, right? Here, for the second method, here change into positive, no? So, total 1 to infinity. Here 1 to infinity. So, here, right? 1 to infinity, how to, here in between, this range is there, no? So, this can be, it is 1 minus the term. 1 minus the summation limit, okay? See here, how to write 1 minus summation n equal to 0 to infinity a power minus 1 z power z the whole power n, right? See here, here the limit 1 to infinity, here changed by 0 to infinity. 0 to infinity means start from here, no, 0 to infinity. In between, 1, the range is 0 to 1, they have 1, the difference is 1, no. So, you have to subtract 1 from the summation term, okay? Okay. Next step, ordinary simplification. 1 minus, write the formula. We know the formula, summation 0 to infinity a power n formula, right? Here write the formula. See here. Summation n equal to 0 to infinity a power n formula 1 by 1 minus a. This is the formula, no? Substitute the same formula here. So, 1 minus 1 by 1 minus a inverse z, because this is a. This is for a, right? A power. Instead of a, you have to write a inverse z, right? Ordinary simplifications, take LCM. 1 minus a power minus 1 z minus 1 the whole divided by 1 minus a inverse z. So, here this term and this term get cancelled. The remaining term minus a inverse z divided by 1 minus a inverse z. Okay. Next step, for the denominator term, take a inverse term as outside, minus a inverse term, take it as outside. So, the remaining is z minus a. So, here this term including minus sign, this term get cancelled. For the final, the remaining term z by z minus. For the conclusion, x of z equal to z by z minus a. This is method 1. Okay, I will explain method 2 also. According to your convenience, you have to manage the steps. So, for the method 2, method 2. Method 2. So, minus sign, no. The same step, minus is outside. Minus is outside, minus 1. How to expand the summation term, okay? A inverse z the whole power 1 plus a inverse z the whole power 2 plus a inverse z the whole power 3. Likewise, you have to expand the term. For the next step, minus 1 already having. Okay, next step you have to take, write the statement, take a inverse z outside. Okay, because for the each and every term having a inverse z, no. So, the common term take it as outside. So, a inverse z, the remaining term 1 plus a inverse z plus a inverse z square plus a inverse z cube. Likewise, you're going on, right, up to infinity. Why? Because as per the formula, here the summations n equal to 0 to infinity, the formula start from 1, okay, because here we know we need 1. So, according to the formula, you have to convert the statement. So, take the common term a inverse z to the outside. The final next step, minus 1 a inverse z. So, the remaining term, write the formula. Here write the formula 1 by 1 minus a inverse z. Okay. For the final step, minus a inverse z the whole divided by 1 minus a inverse z. See here, this term as well as this term both are same. Remaining step as usual. Okay. Here the remaining step as usual. Okay, now x of z over. Next find the ROC, that's region of convergence, right? It's very simple. This is a step. See here, this is the step here, right here. This is a step for ROC, to find ROC. 1 minus a term for ROC. Okay, so take the term 1 minus the term A inverse Z. No, so A inverse Z modulus of Z less than 1. So modulus of Z divided by A inverse can be written as A 1 by A, right? So less than 1. So modulus of Z less than 1. 1 means here A, no, so here A. This is for ROC. Then draw the ROC plot or diagram. It's very simple. Draw x-axis and y-axis. X-axis represent for imaginary part of Z, and y-axis, sorry, here y-axis represent for imaginary part of Z. X-axis represent for real part of Z. Draw the unit circle. Okay, this is for the circle. Here, see the modulus of Z, outer area for Z plane in the square shape, right? Okay, this is for Z plane. Shaded area based on the Z, no, Z condition. See here, modulus of Z less than means the area to be inside of the circle. This is a condition, right? So this is the inside the circle. Okay. So modulus of Z less than is less than A, right? So this is for the pole. One of the pole here, take it as A. Okay. Right. So this is for Z plane. This is for ROC plane. ROC plane. Right. Write the final step. X of Z equal to, write the final last step. X of Z equal to 1 by, otherwise Z by Z minus A. Okay. Z by Z minus A and ROC modulus of Z less than A. That's all about this problem.